Welcome to this lesson on applying the GCF and LCM to fractions. After today's lesson, you should be able to use the GCF to simplify fractions and to use the LCM to make like fractions. So when it comes to using fractions, I know that I use it a lot with baking, hence the cookies in the background. But when we're talking about adding and subtracting fractions, your denominators have to be the same. So in order for that to happen, we have to find a common denominator, and a lot of times we like to just multiply the two denominators together. Well, this can cause us to have a really large number, and we like to work with really small numbers, so the LCM can really help us with that. And then when we have an answer, we like to have, again, the smallest fraction. It's easier to picture in our heads, and so we like to use the GCF to simplify because it's fewer steps. Alright, so going right ahead here, in order to know what we're doing, we have to know our vocabulary terms. So in this case, we have equivalent fractions. Equivalent fractions are fractions with different numbers, but when simplified, they have the same value. So for example, if you're looking at these circles, all of them are colored in the same amount. Here, 1 out of 2 pieces is colored in, but here, 2 out of 4 pieces are colored in. These two are what we call equivalent. So even though this is 2 pieces, these 2 pieces are equal to 1 piece when you put them together. All right. Simplify. So when we're talking about simplifying a fraction means to write a fraction in its simplest form. So when you're writing it in its simplest form, and this could be written a little bit better, to write a fraction in its simplest form, where the only common factor of the numerator and denominator is 1. Okay, so that's what it means when you are putting it in simplest form. You have the only common factor of the numerator and denominator being 1. All right, so in this case, we took 4/6 and we divided both of them by 2 to make 2/3. Okay, so this part right here is the act of simplifying, where we are actually dividing by 2 divided by 2. That's the actual simplification process. All right, and speaking of putting it in simplest form, we have to know that the denominator of a fraction is the bottom number in a fraction, and it always tells you how many pieces you need to make a whole group, and it's also the divisor when it comes to a division problem. All right, simplest form. So before we showed how you could take 4/6 and divide it by 2/2, and you would get 2/3. All right, so we're actually going to use that as our example, as opposed to the example that's on here. It's going to be a little bit easier to draw, so just ignore this for right now. So this right here, dividing by the 2/2, is the simplification process. Simplest form then would be the 2/3. Again, a fraction where the numerator and denominator only have a factor of 1. And then the numerator is the top number of a fraction, and it always tells you how many parts there are out of the whole, and in a division problem it is the dividend. And then least common denominator. So the least common denominator is the smallest multiple that 2 or more bottom numbers have that is the same. So when we're finding the least common denominator, we're using the least common multiple. So here we have 3 and 4, and we listed them and found that their LCM was 12. So therefore, the smallest denominator that they could have that was the same is also 12. Now, you can't use the words interchangeably because least common denominator refers to fractions, so you have to understand you're using the least common multiple to help you find your least common denominator. They will, however, be the same number. Alright, so let's take a look at when we're talking about equivalent fractions, we have to remember that if we go from 1/2 to 2/4, I know that I'm multiplying my numbers because the only way to change fractions to make equivalent fractions is to use multiplication or division. You cannot use anything else. Okay? So to make these numbers larger, I had to multiply both the top and the bottom by 2. I took 1 and I multiplied it by 2, and I took 2 and I multiplied it by 2, and I got 2/4. Now, this doesn't mean that this number got larger. What that means is if I have 1/2, so here's my pizza, and right now I have 1 out of 2 pieces. Well, here what I did, when I multiplied by 2, I said, okay, well, I'm going to take this, and instead of having it be 1 piece, it's going to be 2. And instead of having this be 1 piece, it's going to be 2. So then now, instead of this being 1 out of 2, it became 2 out of a total of 4. Okay, so what's important to remember is what number can we multiply and still get the same number? So what number allows us to multiply another number and still get the same number? The multiplication property, identity property, tells us that that number is 1. Anytime I multiply a number by 1, my number stays the same. Well, let's look at this. We have 2 over 2. Well, 2 over 2 is equal to 1. So when you're multiplying your fractions, you're multiplying it by something that's value is equal to 1, which means that the value isn't changing, just the look of the number is changing. So 2/4 has the same value as 1/2, it just has a different look. So whenever you want equivalent fractions, this number that you multiply or divide by has to be equivalent to 1. Otherwise, you are not finding an equivalent fraction. Okay, so remember, it's that golden rule in math. Whatever you do to one, you have to do to the other. So here, whatever you do to the numerator, you must do to the denominator. And again, when you multiply a fraction to make an equivalent fraction, that does not mean the fraction got larger. They're the same size, it's just the numbers that got larger. So here, let's take a look. We have 1/4 and we multiplied it by something to get 8/32. Well, it's really nice when I have 1 because I know to go from 1 to 8 I had to multiply by 8. And what I do to the top I have to do to the bottom. Alright, same thing here. To go from 1 to 5 I had to multiply by 5. And then I know what I do to the top I have to do to the bottom. So I had to multiply by 5. I double check. 2 times 5 is 10. So 1/2 is equivalent to 5/10. And 1/4 is equivalent to 8/32. So again, these two numbers here aren't larger. They have the same value. It's just the numbers look different. Okay? And in all actuality, these actually got, so our pieces actually got smaller because before we had one giant piece, that one giant piece was cut into 8 little pieces. So that means all 4 of those giant pieces were cut into 8 little pieces, giving us a total of 32 pieces. All right, here what I want you to do is I want you to try these problems on your own, but you're going to pause and come back and check your answer. So here, to go from 4 to 48, I know I had to multiply by 12. What I do to the denominator, I have to do to the numerator. So I'm actually going to do the multiplication, and you should have gotten 12/48. To go from 8 to 64, I have to multiply by 8. So what I do to the denominator, I have to do to the numerator, and so here I get 56. All right, how do I know if a fraction will simplify or not? Easy. They have to share, the numerator and denominator have to share a common factor. And that common factor has to be bigger than 1. So let's take a look at 6 and 10. So 6 and 10 have 6 and 10, and we're going to look at those factors. So here I have 1 and 6, and then I have 2 and 3. Here I have 1 and 10, and I have 2 and 5. So they have a common factor of 2, which means it can be simplified. So 6 and 10 both can be divided by 2. Now, I can't write that I'm dividing by 2 like this because that is actually not the same thing as what we're doing. You have to remember that you're doing 2 and 2. So what I'm doing to the numerator, I'm doing to the denominator. Okay, if I look here, I know 7 is a prime number, so it's only divisible by 1 and 7. I know 10 isn't divisible by 7, so it's already in simplest form. 9 and 12. 9 and 12, well, 9 has factors of 1, 3, and 9. I know 3 can divide 12, so I can take 9 twelfths, divide it by 3 and 3, and I get 9 divided by 3 is 3, 12 divided by 3 is 4. Here I know 5 is prime, and actually I can use my divisibility rules. Silly me. 16 ends with a 6, so can it be divided by 5 at all, or anything that could divide 5? Absolutely not. So this is already in simplest form. Alright, so let's take a look at when we put things in simplest form, what that's going to look like for us. So in all actuality, when we divide, we like to look at it and go, oh, 8 and 24 are both even, so we can divide them both by 2. And then I get 8 divided by 2 is 4, and 24 divided by 2 is 12, and that's great. That is simplifying it. However, it's not being put into simplest form, because still, we can divide again, and we get 4 is divisible by 2, 12 is divisible by 2, and I get 2 sixths. Well, again, I can divide this fraction, so I'm going to do 2 divided by 2 and 6 divided by 2, and I finally get down to 1/3. So this took me 1, 2, 3 attempts to get into simplest form. So that's why we want to look at using the GCF, because here I could have used a larger number to divide by, and it would have taken me less time. So let's look at how we do that. To do that, we're going to look at the smaller number. So in this fraction, we have 28. And we're going to list its factor. I'm sorry, 20 is the smaller fraction. So we're going to list the factors. We have 1 and we have 20. I know that 20 is also divisible by 2. 2 times 10 gives me that 20. It's divisible by 4. And it's 5 that gives me that 20. So my factors are 1, 2, 4, 5, 20, 10, and 20. Okay, so then now what I can do is I can, after I've listed the factors, so I look at the smaller number, I list its factors, and then I start with the largest number on the list and think to myself, will it divide the larger number? So 20, will it divide 28? No, so that won't work. 10, will it divide 28 evenly? No, so that won't work. 5, will it divide 28 evenly? No, so that won't work. 4, will it divide 28 evenly? Yes, it will, so that will work. 2 would have worked as well, but since 4 is larger, that's what we want to use to get down to our smaller number faster. So 20 divided by 4 is 5. 28 divided by 4 is 7. So here it took us 1 step of division instead of 2 to get to our answer of 5/7. Okay, the largest number that you say yes to is the GCF, and then we can divide that numerator and denominator by that number. So 4 is the GCF of 20 and 28, and that's what I use to divide so I could simplify my fraction. So let's do 2 of them together. So here I have 15 and 20. So if I look at 15, I have 1, 3, 5, and 15. And as you go further in this and get better at it, you won't have to list those factors. If you're more comfortable with it, list both sets of factors. So here I have 1, 2, 4, 5, 10, and 20. Okay, 20 doesn't work, 10 doesn't work, 15 doesn't work, but 5 does.
So I can divide, since 5 is my GCF, I can divide both of these by 5 and I get 3/4. Let's look at 18/27. So again, I have 1 and 18, 2 and 9, 3, which means I have to have 6, and then 4 and 5 don't work. So here, I can look at 27, and I know 18 won't work, but 9 will, because 2 plus 7 equals 9. 9 is a multiple of 9, so that means 27 is divisible by 9. So I could have divided both of these by 3, but I would have had to done that 3 different times to get to my answer. So my GCF is 9. I do 18 divided by 9, and it gives me 2. 27 divided by 9, and it gives me 3. These two problems you're going to do on your own, and we're going to check them in class. All right, moving right along. When we're talking about adding fractions, it's like when you go to the grocery store and say, I want to go buy 6 apples. Well, you can't pick out 5 apples and then a lemon. It works kind of the same with fractions. You have to add apples and apples. So if I have tenths, I have to add tenths. If I have thirds, I have to add thirds. I can't add fifths and fourths without doing some changing. All right, and let's look at how we do that. So here, if I'm adding 3/4 plus 4/5, my first step is to find the least common multiple of those two denominators. Like we said, this is also called the least common denominator. So here I have 4, 8, 12, 16, 20. And here I have 5, 10, 15, 20, and I already have my least common multiple. So that least common multiple is 20. So that tells me I need to take I need to take 4/5, and I need to multiply it by something to get me to a denominator of 20. And I need to take 3/4, and I have to multiply it by something to get me to a denominator of 20. Well, whatever I multiply the bottom by, I have to multiply the top by, so I know this has to be another fraction. Here I know it's 5 times 4. What I do to the denominator, I do to the numerator. 4 times 4 gives me 16. Here I know I multiplied by 5. What I do to the denominator, I do to the numerator. So 3 times 5 gives me 15. And then now, since I have 20ths and 20ths, so I have apples to apples, I can add. I can add my 15 20ths plus my 16 20ths. And I get 31 20ths. Because this is an improper fraction, I have to change it to a mixed number. 20 can go into 30 one time. I have 11 left over out of 20. Now in this case, I have 1 and 11 20ths, so I do not have anything to simplify. It's already in simplest form. Please do not get the process of converting from an improper fraction to a mixed number confused with simplification. Simplification is when you are taking your fraction and you are reducing it by the same number on top and on bottom by using division. All right, so we're going to do 2 examples together. We're going to do one of subtraction and one of addition. Okay, so let's take a look at, well, and actually I'm going to do both subtraction. Well, no, we'll just do the top ones. So here I have 20 and 8. So my multiples of 8 are 8. Well, actually, let's do 20, because since it's bigger, if I do 20, I know there's 20 and 40. Well, I know that 8 times 5 gives me 40, because 8, 16, 24, 32, 40. So if I know my multiples, this will go a little bit faster. If I don't, that's okay. I just need more practice. So now, instead of using 80, I'm going to use 40. So 15 20ths has to be multiplied by something to give me 40ths. I know that that something is 2, so I multiply the numerator by 2, and I get 30. And then 3/8 has to be multiplied by something to give me 40. I know that something is 5. What I did to the denominator, I do to the numerator, and I got 3 times 5, which is 15. The order is really important. So 15 20ths went first, so 30 40ths has to go first. Minus 3/8 was second, so that equivalent fraction of 15 40ths has to go first. Now I can subtract. 30 minus 15 is 15 over 40. I know that I can simplify here because they both end in 5 and 0, a 5 or a 0, so I know I can divide both of these by 5. And I know that it's my largest common factor. I get 15 divided by 5 is 3. 40 divided by 5 is 8, so my answer is 3/8. All right, so in this case, I have 7 and 3. My first 5 multiples of 3 are 3, 6, 9, 12, 18, 15, sorry. And then 7 is 7, 14, 21. Well, when I hit 21, I think that's a multiple of 3. So 15, 18, 21. So yep, 21 is my least common multiple. So in this case, my least common multiple is my two denominators multiplied by each other. That will happen from time to time. So 6/7 times 3 over 3 gives me 18 over 21. And then 2/3 times something has to give me 21, and I know that something is 7, so the numerator has to be multiplied by 7, and I get 14 21sts. Again, I'm going to add, but I'm going to put them in the correct order, so 18 21sts plus 14 21sts. 4 and 8 is 12, carry the 1 is 32 over 21. 21 goes in the 32 one time. Okay, and that gives me 11 left over out of 21. 11 and 21 don't have any common factors other than 1, so it's already in simplest form. All right, so same idea. You are going to do these two problems on your own, and we will check them in class. You will be doing a lot of practice in class with converting and adding and subtracting and all that. So if you're still struggling with the part where you're adding and subtracting the fractions, don't worry about it. But I really do want you to practice finding that least common multiple to use it as the least common denominator. As always, if you have any questions, please be sure to write them down or email me so we can go over them in class.